Currently, I am pursuing a BTech in Electrical Engineering at IIT Madras. Till now, you guys have done the first two modules, which were microcontrollers and digital designs, both of which forms the basics of electronics, electrical, and communication. Today, we are going to start something which is more of a industry specific, to be honest, like signal processing. Signal processing is basically used at a lot of places at present and is one of the most important tool in the field of technology. Okay, I'll just start with it. So, okay, before I dive into the content, I'll take you guys through, like, this is something you should always follow. The golden circle
Processing
rule.
is basically used
You
at
should
a lot
always
of
ask
places at
what
present.
is the purpose, like why are you doing something, how are you going to do that, and what are you going, like what exactly are you doing. So like we'll answer all these three questions in a sequential order from inwards to out. Let's start with the what's the purpose of this meet, like why are we studying signal processing. So there are multiple domains in which we can use signal processing, one of which is, let's say, audio processing. So audio processing is something very important. Like we can see audio processing tools being used everywhere, like your Google Assistant. You press the mic button, you say something, and that gets detected. Or let's say you are driving a how do I say, automated car, self-driving cars, where you give commands and the things get executed. Even the earpods you use, they have uh, noise cancelling features. All of these are like outcomes of audio processing. So what I'm saying is audio processing is a type of signal processing which plays a crucial role in audio recording, editing, and mastering. Now, what all uses I said were kind of basic, right? I'll take you through an interesting project that uses audio processing. So this is a digital stethoscope. Like if you guys see Shark Tank, then these IIT Bombay people came there with this project. So like there's a lot in this project, but the main part is when you use a stethoscope to listen to someone's heartbeat, the like the sound of the heartbeat is not very clear. There will be a lot of noise and it's very less. So you need to be an experienced doctor to analyze the heartbeat or to give some feedbacks, right? What these IIT Bombay people have done is they created a digital stethoscope which removes the noise from the heartbeat, amplifies the heartbeat, and then processes it. So that's something which made, like there's a lot more what they have done. I have attached the link. You can go through that later maybe. But yeah, that's where they used audio processing. Even at IIT Madras, we also have a startup that's currently working on this thing. You can like add more components to that. Maybe you can add machine learning to process the heartbeats and record abnormalities and to detect if the person is going through any heart related problems or something. Then the next thing is medical imaging. This can be another use, or I can say another type of signal processing. Basically everything, whether it be an audio, an image, or a video, everything is signal processing at the core level. So your X-rays or MRIs, all of these come under signal processing, medical imaging. Now this was medical imaging. There's something called like there can be a bigger aspect to image processing. Like we have drones in armies, right? Like the armies uses drones which can be used to detect mines planted at some places. All those come under image processing. Even your Google Assistant, it has a camera built using which you can like search. You show it an object and it tells what the object is. That is also a type of image processing. The third use can be communication systems. Like you're sitting in India and you call someone in Paris. Within a second or so, you get connected to that person, and your voice is also very audible, very clear. So all of that is possible because of signal processing. Now, in this session, I'll mostly try to take you guys through the three major parts I have mentioned till now: how audio processing is done, how image processing is done, and how signal processing is used in communication systems. So with this, we have like there can be many more applications to signal processing. I have mentioned just the three. There can be biomedical signal processing. Signal processing is also used in finance, like to analyze stock markets and all. So all of that like would be too much to cover in just one session. So I've chosen the most important ones and will take you guys through them. Now we have the purpose. We also know how we are going to achieve it. That is signal processing. So let's see how can we do that. So okay, firstly I'll tell you guys like this module we have divided into 3 sessions, and signal processing involves a bit of mathematics also. So we have tried to keep the mathematics and the computation part in the mostly in the second and the third sessions. In this session, I'll just be taking you guys through some basic tasks to to make you interested in signal processing, and basically like what is it used for, and we'll do some small tasks. This session might also be a little smaller than other sessions. So yeah. We'll start with the first one, that is audio processing. So in audio processing, there can be multiple things. I have handpicked one thing that is called speech recognition. Now, I'll tell you in brief what speech recognition is. So when you press the Google Assistant ka mic and you say something, then you would have seen that whatever you speak gets converted to a text and is typed on Google. And then further search mechanism is executed. So now this speech to text conversion is called speech recognition, and we'll like in this part only we'll be writing a basic small code to actually implement speech recognition. So I'll just read once whatever I have written. Speech recognition technology enables machines to convert spoken language into text or commands, enhancing accessibility and automation across industries like customer service and healthcare. It powers virtual assistants, facilitates real-time language translation, and aids professionals in dictation tasks. In vehicles, it supports hand-free operations for calling, navigation, and entertainment. Advancements in machine learning have improved accuracy, making speech recognition integral to our digital interactions and likely to expand further in the future. So like I'll be taking you guys through a basic code. So what you will see in that code is you will process let's say your voice. uh, Whatever you will say won't like it won't be converted to text with 100% accuracy. There will be some error. That may be because your voice was not clear, your audio was not clear, or that can be some error. Okay. So we won't be doing it in the session, but what you can look up after the session is how can we introduce machine learning techniques to improvise the accuracy of the speech recognition system. So before diving into the coding part, I'll introduce you guys to some important terms. If you have done coding before, you would be aware of what a library is, but despite that, I'll just explain in. So there's like a library is basically a set of pre-written codes that is present in all the programming languages. Like let's say you are given a list of numbers and you want to find the minimum of all the numbers in the list. So what a basic code can be, you'll just iterate through all the elements in the list. You will compare, and you will in the end you will say, okay, this number was the minimum in the list. Now, let's say in C++, there's a library called math.h that has an inbuilt function called min. So you will simply write math.h under, like inside math.h, I'll access the min function, I'll pass the list as a parameter, and I'll get the minimum of all the numbers in the list. Now, how does that min function work? Okay, I'm not sure. There might be some code. There will be some code. There will definitely be some code, but I don't know what that code is. And actually, I don't care what that code is as long as my work is getting done. So basically, library is a set of pre-written codes which we directly use while writing our program. The next thing is API. Now, what is an API? So API stands for Application Programming Interface. I'll tell you guys, like when you go to some new website and you try to log in on the website, there are two options. When you try to sign up on the website, there are two options. One is they give a form like enter your username, your password, your name, your date of birth, etc., etc. Or you are also given an option to sign up with Google, sign up with Facebook, sign up with Twitter, something like that. So those options, sign up with Google, sign up with Facebook, are a type of API. Like when you created your Google account, you would have given all your information to the Google ka server. Now your information is saved in the Google server. Now when you are accessing this new website and you click on sign up with Google, this website requests from Google to give access to information related to you, and then this website gets information from the server, and then like you're signed up for the website within just like 1 or 2 clicks. So that's how APIs work. Like basically there is some feature, some functionality that is created at somewhere, and we try to import that in our code so that our implementation becomes easy. Like we don't need to again write the code. And an API is a defined set of rules, protocols, and tools that allows software applications to interact with each other or with an external service, facilitating data exchange and functionality while abstracting underlying implementation details. Okay, I have this. Okay, this clear. Now, okay, this was not needed, but I'll just mention it that there are different audio formats you all would be knowing, like MP3, WAV, FLAC, etc. Now, audio formatting can be done using any of these formats, but we'll be using WAV format. Like it's easier to work with WAV files. That's why we'll be taking it. Now, I'll just take some 4 or 5 minutes break over here, and like you guys, I'm giving you a task of like record your voice on your mobile voice recorder, or maybe your laptop voice recorder, whatever it is. Just a small audio clip of 5 seconds, 5 7 seconds. You may just say my name is this, that, and then go to Google and convert that audio file to WAV file. Now how can you convert that audio file to WAV file? I'll uh, just a second. Yeah, so you can go to a new tab and you can like type M4A, like check whatever is the audio file type to WAV converter, and you can use any of these first or second slides. Just choose files and convert. Keep that thing converted, and we'll start back in some 4 5 minutes again. Once you all have some audio file ready, uh, I'll just take a break for some 4 5 minutes. Once you guys are done, let me know. Once you guys are done with the audio, like recording your voice and converting it to WAV file, just raise your hand. Days will start again in 2 more minutes. Just try to be a bit fast. Okay, now you guys can put your hands down. We'll start again. If anyone is facing any problem, just put it in Q&A panel right now. So maybe I'll address it. Okay, I think we are good to go. We'll start now. Yeah, so I hope you guys have converted your audio file to the WAV file. Now we'll just start with some coding part. We'll open a Google Colab notebook. So just open a new tab, search for Google Colab notebook, go to the first website. Over here you can see in the bottom left, new notebook. Just press that and that will open a new notebook. Okay, so this is Google Colab ka interface. I hope each one of you have opened it. I'll just wait for a second. So this is the main area where we'll be writing the code. And then in the left hand side, in the bottom over here, you will see something called files. So we'll upload our audio file into this. Like when you click on it, it will load for something. And once it is connected, you will see this option called upload to session storage. Press it and then choose your audio file. In my case, I've named it as ABC. You can name it whatever you want. Just open it. Okay. And now you will see that this audio file is uploaded on the files session storage. Like just a second. Yeah. So in the left hand panel, it is visible as abc.wav. Okay. So just a minute, I'll wait so that you guys can get done with it. Yes. Seven people have still raised their hands. If you guys have no doubts, you can just put them down. Okay, so now let's start the coding part. Okay, so I told you guys about libraries, right? So there's an inbuilt library in Python called speech recognition. So firstly, we need to install that library. And now, how are we going to install? So basically, there's a syntax for installing a library. You start with an exclamation mark. You write pip install capital S speech recognition with capital S and capital R. So you can, okay, so in Google Colab, there are some auto suggestions which you can take. It suggests what to write. You can press tab to get the thing fully typed. So this is pip install speech recognition. This will download the speech recognition library in the Google Colab notebook. Since we are using Colab, which is a coding tool, coding platform, I would say, on cloud, we'll need to execute this pip install thing every time we start a new notebook. But let's say you were working on a local computer IDE, then you could install it from the command prompt, and then you don't need to install it every time. Now, once you have written this line of code, press Shift plus Enter to execute it. Now it will download a library. Just it will take some 1 or 2 seconds, and once it is done, yeah. So now it has a tick sign over here, which means it has been installed. Now I have the library. And now I need to import that library in my code. So we do that using import speech underscore recognition as SR. Now, what does this syntax, this line of code means? So there's something called speech underscore recognition, which has some inbuilt functions which we want to use. That's why we are importing it in our Colab notebook. We are importing it as SR. That means, like I told you guys, if we have to use some function inside a library, we need to access it every time. Let's say there's some function. So, and inside speech underscore recognition, and if you want to access it, every time we'll have to write speech underscore recognition dot whatever the function is. So instead of writing that by speech underscore recognition every time, we'll simply write SR. That's what it means to import it as SR. Now you can again press Shift plus Enter to execute that line of code. I will create an object called R. Just a second. Equals SR dot. So you can see Colab is already suggesting me what to type next. Again, simply press tab to get that thing written, SR dot recognizer. So this is something called recognizer inside speech underscore recognition, which has the functions I want to use. Functions like reading an audio file, converting an audio file to text, something like that. Now, with SR dot audio file. So this audio file is a function inside the SR dot recognize inside the speech recognition library, which is used to read an audio file. I'll put a parenthesis inside the inverted commas. I'll write the name of my file. In my case, it is abc.wav. Then again, I'll import it as source. So every time I have to use this audio file, I'll just refer to it as source. I don't need to write abc.wav every time. Put a colon. This is just a part of syntax. And now I'll listen to this audio file and record it in an audio underscore text. Let's say something that will be R dot listen to source. So this dot listen is a function inside the recognizer layer, which will listen to the audio file and which will just listen to the audio file and capture the audio content in this. Okay, we'll name it as audio only, not audio underscore text. It will capture it inside the audio variable. Now, once we have this audio thing inside the audio variable, we'll use this try. Okay, so for now I'll just write and then I'll explain what it is. So you can see Colab is already suggesting me what to write next. Text equals R dot recognize underscore audio. So this recognize underscore Google part, that is the API, like I introduced to you guys, right? What an API is. So we are using this Google API to convert your audio into the text, and we are storing that text in the variable called text, and then we'll be printing this text. And now this try except thing is just like an error handling. Like you try to print whatever the text is inside the audio clip. If the if the API is able to process the voice, it will print the text. If it won't be able to print, if it won't be able to process the text, just for error handling purpose, we can write print error. That's right, correct? Now we again press Shift plus Enter to execute this file of code. It will take some 2-3 seconds and see it printed over here. Hello everyone, I'm Sarthak Verma from IT Madras. Even though this Verma spelling is wrong, it should be VERMA. Fine. So you guys can try it with your own audio files. I'll give you guys some 2-3 minutes to make sure you are able to reach this stage. Once you are over here, just let me know. If you are facing any problem, write it in a section. People will be replying to you. I'll be replying to you. And also, if your audio is not very clear, very exactly converted into the text, that might be because of like your audio was not clear or something. So try to have a clearer audio clip so that you get this thing. I'll give you guys some 2-3 minutes to get that done. Okay, so someone is asking where can I add the audio file? So when you open the Colab, in the left hand side, you see these are 5 options in the top. The fifth one of these is the files. Just click on this. Over here, you will inside files, you will see this upload to session storage. Just click on this, and then that will open your, like, from here you can select your file, whatever you want to upload, and click on open. That will upload the audio file. It should be visible like this in this panel. So yeah. Okay, someone is saying they got a name error called name SR is not defined. I mean, that must be some typing error you guys are doing. Just make sure it is exactly the same. Import speech underscore recognition as SR. Once you have done this, execute this and go to the next code block. And then you can write it like this. And now then, okay, Henok Peter. You didn't get what? Okay, where can you add the audio file thing? Fine. I'll tell once again. So when you open the Colab notebook, it must have been looking something like this. In the top left, there are 5 of these options, right? The fifth one, this one. I hope my cursor is visible. This is called files. Press it. Inside the files tab, there is this upload to session storage. Click on it. It will open something. Okay, I think that something is not visible to you guys. Just choose your audio files from there and click on the open button. Once you're that, it will get uploaded in the side panel of Google Colab. Okay, and Dhruv Munchal. Yeah, that error, like that was a part of our print statement, right? So yeah, it may mean your audio is not clear, or either your audio file is you're like not writing the correct name of the audio file, or maybe it is not WAV type. So these can be the only issues. Just make sure there's no such mistake you're doing. Anyone else facing any doubts? You can put in the Q&A section now.
This one, this wiki accounts and this will come from the
Okay, who is this? An anonymous user. Someone has wrote like what error they are getting. Firstly, what I can see is you have written R audio equals R dot recognize. So like that should be recognize underscore Google. Next, okay, I think that will be one error. Next, I assume, okay, it says no such file or directory called abc.wav. Make sure you have imported abc.wav in your file and it is named exactly the same. Like what some people do is they will name the file also as abc.wav. Name it as abc and then type abc.wav. So it won't be an issue. So whoever is done with this, can you just raise your hand once?
So that's what I was thinking.
So somebody has shared an image of error on WhatsApp. See, it just says no such file or directory called abcd_summit.wap. Make sure you have uploaded the audio file correctly in the collab panel. Okay.
So this is the thing. We know
Yeah, you can do that also. Copy the path of the uploaded file and paste in the same. That also works, right? Okay. You can see the home buttons. That copy path thing you can do, like just right click on your audio file. You will see a copy path option over here. Click on it, and then what you can do is in this line with sr.audio file, instead of abc.wav, just paste the whole of your, like whatever you copied the path. This will also work. You can execute it. This will also work. Hello everyone, I'm sorry for executing. I hope you guys know you're pressing shift plus enter. We have some 10 people who have done. If you guys have done, like, please raise your hand.
So currently that is in German and what's the database?
No, but we know what action we are doing.
So we all have make sure that the patterns will.
Okay, I think that's a good amount of time I have given you guys. If you guys still face some issue, you can always ask in the group. Okay, what is this? Can you show the rest part of the print text? What do you mean by rest part of the print text? This is the whole code. I'm already showing it. I've defined text by using the Google API, recognize Google Audio, and then I'm just printing the text. The text is only what is there in my audio voice. So I think now I should proceed. You can always get back to me in the WhatsApp group of Summertronics. So yeah. So we have seen one of the first part of signal processing, one of the types of signal processing called audio processing. Now the second part I introduced was the image processing. Now image processing is again a very big domain. There can be multiple things inside image processing. It can involve manipulation and analysis of digital images, restore some patterns within images, segment and recognize patterns within images. I told you it can be used in medical imaging, satellite imagery, biometrics, and various other places. So we'll be using image processing. We'll do a basic task on that also. I'll get back to that. But first, I want to introduce you to some useful things. So again, there's something called OpenCV. OpenCV is also a type of library which we can use for image processing tasks. It has a lot of, I'll again say, since it's a library, it has a lot of inbuilt functions, features, which we'll be using. I'll explain the features while using them. I'll just go through what I've written. So OpenCV is a widely used open source software library designed for real-time computer vision tasks. CV in OpenCV stands for computer vision. It provides a broad spectrum of tools and algorithms for image processing, object detection, video analysis, and machine learning integration. Originally, it was developed. Okay, all of this you can read later maybe. So what we'll be doing is, I mentioned this object detection thing, right? Mostly I'll be focusing on, like our task today will be focusing on object detection. Okay. So these are, like I already mentioned them, what are the uses of image processing. Medical imaging, I already mentioned in the beginning, biometrics and security, satellite imaging. I told something like uh, army uses drones to detect mines and all that comes under satellite imaging. Then document digitization. So you would have seen you scan a document and it gets converted to a typed text. That comes under image processing. There are many more uses. So what our task will be in this image processing thing is I'll be sharing an image with you guys. So that image has, okay, I'll show you what the image looks like. Give me 1 second.
We discuss all of those things.
Yeah, so this is the image I'll be sharing. Okay, the task will be very simple. We have to just detect all the squares in this image and make a boundary against them. Now you must be thinking, what is the use of it? So that's how object detection start. Huh. Our task is to detect these squares. That's how object detection starts. So I'll take you guys through the code again, through the coding part of it. Shiniket, can you confirm once, is my screen visible?
Yes, yes, it's visible.
The presentation is visible, right?
No, right now it's not the presentation I'm seeing. I'm seeing your Teams window, but so far it was visible. I think right now, yeah.
Okay, okay, okay. Let's change once. Yeah. So we'll start the task. I told about the task. We'll be detecting the squares in that image. I'll be sharing that image with you guys. Just give me some 1 second. I'll send it to. I'll send it on the WhatsApp channel, or maybe I'll see if I can put it in the Q&A panel. I'll do that. So yeah, I've shared the image in the Summertronics WhatsApp channel as well as discussion group. Just download the image and in your laptop and be ready. I'll give you some 2-3 minutes. Again, once you guys are done with downloading the image on your laptops, just raise your hand. So are you guys done with downloading the image or you need more time? Just write in the Q&A panel. So I believe all of you are done with downloading the image. Let's get to the coding part. So again, we'll open a Google Colab notebook. Okay. The previous one. And like again, reopen it in the same way. It's fine. So now you have the Google Colab notebook. Again, we'll upload the image. So I told you guys, we'll go to the files. It will connect to the runtime in just a second. Yeah. Now we'll upload. Click on this button, upload to the session storage. Choose the image file, like whatever I have shared, and click on open. Click on OK. This file you can see got uploaded. this file you can see got uploaded. So now you can even double click on the squares.jpg to see the image. So this is the image I'm processing. Now we'll start with the coding part. I told you guys about OpenCV, right? So we have a library for that, which is called CV2. Import CV2. Again, you can import it as CV. Like, instead of writing CV2 dot whatever the function is, everywhere we'll simply write CV dot whatever the function is that we want to use. Now there's another library in Python called NumPy. So I haven't told you guys about NumPy, right? But for now, just assume NumPy is a library which we can use to play with, I would say, matrices. Like we can say that each image is basically a matrix. Like the pixel ka information, you can call it as a matrix ka element. So that's why there are several inbuilt functions in NumPy also. We'll just go through them once we are like while writing the code. So import NumPy as NP. Now, okay, the next line of code, you don't need to worry much about it. Just copy it exactly from google.colab. Okay, see, Colab is already suggesting me what to write. So I can just press tab to get the thing written. Now this third line of code is you need not worry about what it is. So basically there's a function called .imshow inside CV2, which is used to show the image, like print the image basically on the screen. Now that if we were coding in some local IDE, we need not write this line of code, but there's some issue with Colab. We need to write this code to use the imshow function. So we just write it from Google Colab patches, import CV2 underscore imshow. Again, press Shift plus Enter to import all the libraries needed. Now we'll load the image in a variable called img. We'll write cv dot imread. Now this imread is again a function inside the CV library that is used to read images inside the parentheses, put inverted commas and write the name of your files exactly as what you have named it, squares.jpg. Now I have the image file. Now I have my image in a variable called img. Okay, now I'm basically going to use a technique to detect the squares. So I'll first explain you what my method is going to do. So you can see this image has squares of different colors, red, yellow, green, blue, red. We'll convert this whole image in a gray image. Gray image means each of these will be converted to a gray image. Now, why will we do that? Because there's some inbuilt function using which we can detect the boundaries of the gray image. That would be like detecting the boundaries of gray image is easier than detecting the boundary of any other color. So that was the logic I'm going to follow. How am I going to do that? I'll show you guys. So I'll create a variable called gray in which I'll store the image, gray image. So you can see Colab is already suggesting me what to write next. Anyways, I'll just type it out. cv.cvt column. So the CVT color stands for convert color. This is again an inbuilt function in CV. The first parameter being img, like the image I want to, like the image whose color I want to change. Then there's the second parameter in which I will specify what I want to do, color BGR. This is just like RGB, red, green, blue. It's written as BGR to gray. So we're converting the RGB image to a gray image, and we are storing it in a variable called gray. Now, like how do we convert that? So there's again, that's called thresholding. You know, each pixel is can be represented as some values of RGB. Those values range from 0 to 255. So the thresholding part, like what thresholding means is, I'll see a color and I'll decide I want to convert, if the pixel is say, greater than, let's say, some value X, then convert it to black or convert it to gray, something like that. Sorry, if it is lesser than some value X, convert it to black, convert it to gray. And like 0 to 255, I told about the range, right? So, you know, basic color theory, like if all of them will be 255, red, green, blue, then the image will be white in color. If all of them will be 0, then it will be black in color. Yeah, so that's something. Okay, now again, threshold, and I've written underscore comma threshold equals the threshold. So this function is used for the thresholding purpose. I'll convert to gray, and then I'll pass it as 220, 255, see threshold underscore bind. So this thing, yeah, what I am basically saying by this syntax is any pixel below 220 convert it to 255. Sorry, any pixel just convert it to 220. And this function basically just suggests I am binary threshing I'm providing a threshold value. And now why this underscore is here? So this CW threshold function, it returns two different parameters. I'm not sure about the first one, but like we don't need the first parameter, so we can just simply write it as underscore. And the second one we are storing in a variable called threshold. I hope I'm clear up to here. Let's see what's okay. Yeah, fair. So next, now we want to find the contours, right? Contours basically means the boundaries. So we'll create a variable called contours. Right, underscore. So you can see Colab is already suggesting me the whole line. So I'll press tab and yeah, this line looks correct. So I'll explain what it is. There's a function called find contours. Pretty obvious what it does. Like we can find the contours using this function in the thresholded image that we're passing as the first parameter. Now these other two things, they are actually not required, but like the function won't run without passing them. So there's some hierarchical relation between the contours, like one is inside the other, something like that. So these functions are like used for just providing that those hierarchical relations between the contours, but we don't need like the hierarchical relations in this task. That's why I've given this second result as underscore. Like this function also, same as threshold, this find contours also returns two results. One is the list of the contours which I'm storing in contours, and the other one is the hierarchical relations between the contours which I don't need. So I'm storing them in, I'm not storing them basically, I'm just writing underscore in place of any variable. Okay, now this contours variable has the, I would say, the coordinates of all the contours, like all the boundaries which we are supposed to draw. So now we'll just use again an inbuilt function called draw contours. I mean, with the name only, it is pretty much clear what this function is doing. The first parameter I'll pass is the image on which I want to draw the contours. Second is, of course, the contours. I'll tell the function what contours I want. Now, I told you guys this contours is a list of all the contours that we want to draw. So the third parameter, you can choose how many of those you want to plot. So at present, we want to plot all of them. So we'll just write -1. -1 basically means we're plotting all of them. Now, this fourth parameter, you will basically pass the RGB code of the color of the boundary you want to create. So let's say I want to create a black boundary. So I'll just pass 0, 0, 0. I told key if all RGB are 0, then it is black in color. And then the last parameter which we pass is the thickness of the contour. Let's say we write it is the thickness of the boundary which we are drawing around the squares. And just the last line, which is used for displaying the image. I told you guys, key. After making all these changes, we also need to display the image. Otherwise, how will we know okay, we have done that? So this final line is CV2 underscore IM show IMG. So this line is specific to Google Colab. Like if you're using some IDE, then you can also directly write CV2.im show. That will also work. In Colab, that gives some error. So we'll use this. Now just press Shift Enter, and you can see this was my image. It has some boundaries drawn against all the squares. I'll increase the thickness maybe. Instead of 2, let's write 5. Again, press Shift Enter. And yeah, the boundaries are very clearly visible. So you can see this outer lake, this thing, the whole image also got a boundary. This was what I was telling about the hierarchical relationship between the contours, right? So the hierarchical relationships over here are like this only. Key. This outer contour has these 4 inner contours. I mean, we don't need that information. That's why we never bothered about it. So yeah, this is how we can draw the contours. So basically, we detected all the squares, irrespective of the fact that some square was straight, some was inclined at some particular angles. Like we can there can be further modifications to this code, using which we can also determine these angles and the center of the square if we want. We can do anything we want. Yeah. So, but we won't be doing that in this session. That would be too much. So yeah, I'll give you guys some 5-7 minutes. Go through the code, try to write the thing, and write in the Q&A panel if you have any doubts or if it gives some error. And once you're done with it, again, just raise your hand so that I get to know you're done with it. Okay, I'll give you guys 5 minutes. If you have any doubts related to this code or the previous code, you can put in the Q&A panel. Okay. So someone is asking me to explain the third line of code, the threshold. Okay. So, okay, I think I was not very clear over here. I'll go through it once again. We are passing these four parameters inside the cv.threshold function. The first one being the gray image. Like we have converted our image into the gray image and stored it as GRA value. We're passing that as the first parameter. Now, the fourth parameter, cv.thresh underscore binary. This is a type of threshing, binary threshing. You know, in binary, there are only two numbers, 0 or 1. So that's what we are doing. Like either the pixels will be set to maximum or they will be set to minimum. Now these two middle parameters are just determining if one pixel ka information is greater than 220. It should be set to 255. Right? It should be converted to a white color thing. So in our gray image, we are basically making the image clearer. Like in gray image, whatever pixel will be greater than 220, we'll just change it to a white color, and anything that will be less than 220, like lesser the pixel, more it will be like gray or black. So like our squares will be gray in color, so they won't be affected by this. They'll be set to, like, they'll stay whatever they like, however they look like. So yeah, that's what and then this dot threshold function returns two values, one of which is like the first one I told I'm not sure, but we don't need that. That's why I've written underscore. And the second one is a thresholded binary image, which I am storing in the variable called threshold. I hope I'm clear with that. Okay, I'll show you guys one thing. So we created this gray, right? Firstly, I'll show you what I mean by saying each image is a matrix of numbers. I'll just write a line of code like print gray. Press shift plus enter. You can see it returned a matrix. Like this matrix is very big, so it is not showing all the elements. But wherever this 255 is present, that means that area needs to be white. Now, of course, it's not fully visible because like most of it is 255 only, because most of the image area is white in color. So yeah, this is, any image is a matrix of numbers in at the code level, and I'll show you how the gray image looks like. It is this similar to this cv2 underscore I am show and pass gray. Press shift enter. So this was the gray image we converted. We have this gray image, right? In this only we converted our main image to this image. We detected the contours, then we drew the contours using black color, and then we again showed the on the original image and showed it. That's what my logic was, which I explained initially. Again, once you guys are done, just raise your hand so that I get to know. 2 more minutes, guys, and then we'll start. Somebody is saying module CV2 has no attribute image. I don't get it. Where are you using the attribute image? This was yeah. I don't see image being used anywhere. Let's check your code once. Manish Kumar, I guess. Cool, cool. Okay, okay. All of you can put in first time. We'll now start with the last part of the session today. If you guys have any doubts regarding the 2 codes we have done till now, always put in the group after the session. We'll reply to you. Also, those who have done, they also can reply, try to find what the error is. Okay, we'll proceed for now. So, okay, yeah. Now, the last third use one, what I stated was communication signal processing. Now, of course, like demonstrating the whole communication signal processing is not a feasible thing. We can't do that. But I'll still try to give you guys a taste, like how what is done in a communication signal processing. So this is how the typical communication pathway looks like. So you give some signal as an input. That signal is encoded. You don't need to know what an encoder and all is. Just assume there's something which encodes the signal, modulates it, and then it is passed through a channel. And then at the receiver end, it is again decoded, or whatever the signal you passed, and then it is again converted using decoded, and then the signal is given to the user at the receiver end. Now, this is just an overview I gave you guys. You can always look into it, what an encoder or a decoder is. But there's this problem. There's one problem in this mode of communication, which was shown here, like the right side. When the signal is passed through the channel, some element called noise gets introduced into the signal. Noise is just like disturbance to the signal, which can be introduced through multiple reasons. Like there can be external factors, there can be issue in the channel due to which these noise got added to the signal. Now, I just told you an overview of what noise is. Noise is basically an unintended and unpredictable variation or interference that alters the intended signal in a communication or electronic system. Now, I mean, I can't do much in demonstrating what communication signal processing looks like, but I'll try to show what noise looks like. And before that, I'll just introduce another term called Gaussian noise. Now see, noise is, I told it's random. There need not be any pattern for noise, right? But for our purpose, we have created something called Gaussian noise. Like it's just a type of random disturbance. I won't call it not random, but yeah, it is a random disturbance which follows the Gaussian curve. Like Gaussian curve means normal distribution. That and all, you don't need to worry much about it. I'll show you in the code during the coding part. So again, open the Colab notebook. You can open another Colab notebook. Yeah. So we have the Colab notebook. What we'll be doing is just a basic thing. I'll create a signal that will be a sine wave, and then I'll add some noise to it and show you guys what exactly noise means. So we'll again start by importing the, let's move it a bit. We'll again start by importing some basic libraries. I told you guys about NumPy. It is a library using which we can play with matrices of numbers. Then we'll import a matplotlib dot pyplot as PLT. Now this library matplotlib.pyplot, it is used to draw graphs and play with the graphs to be frank. And we are importing it as PLT, means any function inside this matplotlib.pyplot can be accessed using PLT dot whatever the function is. Just press shift plus enter to execute these 2 lines of code. You can see it's buffering. So yeah, it got executed. Now I told you we'll create a sinusoidal signal first. So we need some parameters for the signals, right? We'll say like the frequency of the signal. Let's keep it 5. We'll see if we need to change the values later. Then, okay, we'll take something called FS, that is sampling frequency for the signal. I'll keep it at 1000. Now, what does sampling frequency means? I'm taking 1 point at every 1000th of a distance, take with respect to time. Means not just defining this parameter will do that. I'll create a time array called np dot. So now I'm accessing a function inside NumPy called arrange. I'll set from 0 to 1. Create take a point at every 1 by fs distance. So like in my T is an array in which I have points starting from 0, ending at 1, and the points are located at 1 by 1000th of a distance, 1 by 1000th of a second. So I have my D vector. Now I will simply create a signal that is pretty simple to do. We'll just use an inbuilt function of np called np.sine. You can press tab at this point to get the whole thing written. So now we have the sine curve whose frequency is 2 npi. Okay, this pi thing can be accessed, pi value can be accessed using np.pi. We have set the f underscore signal as the frequency of the signal, and we have the time array. So it will take up each point from the T array and then plot it on a graph. So firstly, we'll plot this signal first, sine signal only. Let's do it like PLT dot plot. We want to plot time on the x-axis, so let's see T. We want to plot signal on the y-axis. We'll write signal as the second parameter. And for now, let's just press shift plus enter. So this is a sine plot I got, correct? Okay, yeah. You can, like in that last line you can write PLT dot grid as a parameter you can pass to, which means it will show the grid. So now we have this grid top of thing. I think we should change the frequency a bit. I'll make the frequency as 2 and then execute this. Yeah, now this looks nice. This is sine. You know, it lies between -1 and 1, and we are analyzing it for t between 0 and 1. You can decorate this graph using multiple functions inside PLT. If you want, I'll show you later what all those functions can be. But for now, let's just add some noise to this. So I told you about the Gaussian noise that we'll be adding. So you would have studied in your maths what a standard deviation is. We provided a standard deviation, the noise, a standard deviation of 0.3. We'll create a variable called noise. As I told, it will be a random thing, like the noise is a random thing, so we can use a function inside NP called random. And then I told you we want it to follow the normal distribution, like we're just talking about Gaussian noise. So we'll write normal. The next thing is we'll pass parameters like 0, comma, standard deviation, comma, what was my signal? So this variable I have used here is signal, right? I want to add the noise on the same shape as the signal dot shape. So now I have the noise. I'll create a noisy signal. That is simply signal plus noise. So now I have a noisy signal, which is a noise added to the signal. I'll simply plot this noisy signal also. PLT dot plot. On the x-axis, I want time. On the y-axis, I want noisy signal. Again, I'll write dot grid equals true, and yeah, that would be enough. Let's just press shift plus enter. So you can see this is still a sine wave with a lot of noise in it. Now that is something. Okay, you guys just go to the coding part first, and then I'll explain you how to deal with the noise. And yeah, you can get back to me in the Q&A panel if you have any doubts. Yeah, and once you're done with this much, just raise your hand so that I know. Okay, guys, are you guys able to see the Q&A part? Yeah, some people are not able to access it. I mean, I don't know what's the problem. It's fine, it's fine. You can put the doubts in the group also if you're not able to access the Q&A part. Also, this attendance has been sent. You can fill the form for attendance. The attendance form will be closed after the session ends. So, yeah. Okay, I guess nobody has doubts, or if you guys have any doubts up till now, you can just put it anywhere you're comfortable. Put it in the WhatsApp group or put in the Q&A panel. It'll be fine. Okay, Manish Kumar, you can just close. I think you have opened multiple tabs of Collab. Maybe you can close the already open tabs, like which you don't need. Uh, Mahesh Gadkar, there's some issue with your audio file. Maybe try another audio file and yeah, try converting it to WAV file. I guess you've converted it to something called PCM WAV. That won't work. Maybe use another website for conversion. That will work. Yeah. Okay. Thank you for sending the attendance sheet in the group. Sure. We have some questions in here also, I guess. Okay, just some 5 more minutes, guys. After that, you can leave. Okay, fair. So this noise thing is actually a problem in the communication channel. Like it it interrupts in our communications. So how can we solve that noise problem? Is by using something called filters. Now we have a specific session designated to teach you about filters. The last session will be dealing with the filters. So filters are nothing, they're just used to clean up and modify the signals and they remove the noise, improve the clarity and the quality of the signals. So yeah, that's all from my side. Stay tuned to learn about the mathematics involved in the signal sense processing and also about the filters we'll be teaching in the final session. So yeah, thank you very much. Thank you for attending the session. You can leave now. Any doubts, you can always post in the discussion group. you.